Hey, welcome back. Here we are. And now we know how to declare variables, right? We give it a data type, we give it a name, and then we can assign it with the single equal sign assignment operator, and then we give it value. And the value has to match the data type that we give it. So integer has to be integer. So we have data. Now our programs in our software that we're writing has to be able to make decisions. And we need to be able to control this. So we're going to talk about conditional statement, the if statement, and we're going to do a little looping. And you'll see that loops they're a pretty simple thing to do. And then when we get done with this, we're going to go into functions, and then we're going to start programming, and you're going to be able to write whatever you want because you're very smart. So this won't take very long, and then we'll do some examples. I'll bring up some Visual Studio stuff that I wrote, and we'll just look at what it looks like syntax-wise and how it goes. So our first thing, flow control determines the order in which statements are executed in a program. So we get to determine how things go because software makes choices. We tell it because we're the developer. So we say, hey, if the user wants to go right, then he'll tap the right key. If right key is tapped, go right. Left key is tapped, go left. So those are the things that we have to decide. The user puts in information or the program is doing something and it counts down like, hey, I want you to turn off the computer when the counter gets to 0, something like that. All right, so it enables us to make decisions and perform iterations and execute blocks of code based on those conditions. Iteration just means to do something over and over again. So that's our looping structures. Conditional statements allow the program to execute different code based on specific conditions. And some of these examples are if else, and then else if, and things like that. So let's look at this because this is what the computer gets to decide, a yes or no question. And the computers are good at that, but we have to guide it and say, hey, you're going to make a decision, and if this is true, do it. If not, I want you to do something else. That way it can do multiple things. Now our if statement is simple because it's an if statement and our keyword is if. If condition, and condition goes inside of the parentheses. So if condition, bracket, and run your code block. So this will execute the code block or what's inside the two brackets, right? Let's get my little pen as we like. So this, if this condition is true, if this evaluates to true, and we're going to talk about the conditional statements, but if this condition is true, do this. Okay, that's pretty simple, right? If this is true, do the code block inside of here. If it's not true, we're going to have a default. And this is a simple if-else statement. And later on, we'll get to tyranny operators and things like that. But right now, we know the if condition because we just saw that. But what about else? So the other slide, if it was true, do it. If not, just keep on with your program. This says, if this condition is true, do it. But if this condition is not true, do this automatically. So this is like, if light is the same as red, stop. If not, just go. Don't have to check for anything else because it's not red, so we're going, right? If it's red, stop. If it's green, go. If it's yellow, go really fast. So this only execute if, whatever condition this is. And notice we have parentheses and brackets, and then we have else with brackets, okay? So that's our if else. We'll look at these in code after we're done. Now, we have our else if that we'll get to, but we talked about those conditions, and these are our comparison operators. So these allow us to compare things. So inside the parentheses, if and then a parentheses, it has to come to a yes or no question. It has to evaluate to a bool, a true or false. And we know a bool is a true or false. So these have to evaluate to the true or false. And these are our comparison operators. So we're just comparing two things. If x is the same as, see the two equal signs? The same as, comparison operator versus the single assignment operator. So if you do if x is the same as y, that would be true. We also have not the same, and that's exclamation point equal sign. So if x is not equal to y, they're just yes no questions, true false questions. If x is less than y, Notice these are also, comparison operators are also binary operators because they need two operands. You need to compare one thing to another. Okay, so you need to compare one thing to another. So if x is less than y, run it. If x is greater than y, run it. Now we have less than or equal to y, and we have equal or less than or greater than or equal to y. There's no equal to or greater than. You always have to evaluate the greater than or less than first. So these are our comparison operators, and these are what go in your if statement. So if I want to make sure that two values are the same, I would say if x is the same as. Don't say equals to. Same as y. And if so, it's true. So those are our comparison operators. Okay. Now we're going to get into loops, and these are iterative control statements. These allow separate execution of blocks of code. We have our for loop, right? This is one thing. Where'd you go? So for loop, a while loop, and a do while loop. We also have recursion, but we'll talk about that later. So a for loop is just going to run as many times as we tell it to. A while loop will always run when the condition is true. And a do while loop is a cool loop because it always executes a condition before it goes into the loop. We use do while loops for things like passwords and stuff like that. So we'll see what these look like. So let's look at some of these things. Again, we're going to do for loop, while loop, and do while loop. And the thing about loops, if you understand one loop, the process is all the same. If the programming geniuses came down from Program Olympia and took away two of the loops, we would still be fine. They do the same thing. They just repeat code when we tell it to and how many times we tell it to. So let's look at our for loop. For, so that's good. Oh, we don't have to remember the keyword, right? The keyword for an if statement is if, and the keyword for a for loop is for. So then what do we need? These are the three things that happen in every single loop, right? We have to initialize where we're going to start. We have to get to a condition that stays true until we want it to stop. And then we have to update the initialization to get to the condition. If we don't update to get to the condition, the loop will run forever. And while that happens, and we do things sometimes on purpose, it's not good programming standards when you're learning to program to have a forever loop. So we have to initialize something. So look at this. Remember how we declare variables? Well, what are we doing? We're declaring a variable called I. That is an integer. And I is going to be the value of 0. That's my initialization. My condition is as long as I is less than 10. And my update, see the plus plus, that's called increment. And that just means plus 1. So I is 0. So this will run starting at 0. I is less than 10, so that's true. Now I is 1. Okay, then it just stays between here until it gets back and forth. So I initialize, and then I moves and it checks against the middle. Then I moves and it checks against the middle. Then I moves and it checks against the middle. Every time that runs, and as soon as I gets to 10, it stops. This runs from 0 to 9. That's 10 times, but goes from 0 to 9. And it executes whatever we want inside of our code block. So remember this, initialization, you have a condition that has to remain true until you run out, until you tell it when to stop, and use your update to meet that condition so it's not true anymore. And that's our for loop, okay? Now our while loop is a deconstructed for loop. The keyword for our while loop is while. Well, that's crazy. And then this is what we want to stay true until we don't want it to run. We want this to run as many times as this is true. Our condition is true. It executes the block repeatedly as long as the condition remains true. And then the condition is evaluated before each iteration. Remember, initialization, condition, and updated. So a while loop is a deconstructed for loop. That's it. So I have to initialize. I have to start somewhere. So I'm going to say initialize I to 0, just like we did in the for loop. But it's not inside the parentheses. It's just hanging out. And then while I is less than 10. Okay, I is less than 10, so it's going to come inside the block and run. Now remember this right here, I++. it's going to increment by 1. That's called the loop invariant. And it's going to increment by 1. We're in control of how much it increments. We could say I plus equals 2. And then it would only run 5 times, right? Because it would get to 5. Or start at 0 and it wouldn't get to 10. So what do we have here? Initialization is this. Condition is this. And how do we meet this condition? This. If we don't update inside of our while loop, that'll stay true forever and it'll run forever. So we get to turn it off with this update. So it's just a deconstructed for loop. Sorry I made a mess of the thing. Now our do while loop. Do while loop's awesome. Everybody loves the do while loop. Okay? Because what it says is do something, right? While it's true. Okay, I'll do something while it's true. So we have the same thing, initialization, condition, and update. Initialize, I equals 0. Increment I, and then say hello. And do that while I is less than 10. Okay, this is my condition. This is my update in my do loop. So what's it say? I is 0, now I is 1, print hello, and then 1 is less than 10, so do it again. Do it again, do it again, do it again. As long as this while loop is true, what you want to execute is the do statement. So the do always runs first. And that's the thing about the do while loop. You always get one iteration, where in your for loop and your while loop, you could skip the whole thing if it doesn't work. Okay, so the do always is. And why is this good? Well, let's say I said string name equals password, and I say do, and then I say if password does not equal, or if password does not equal password, ask again, ask again, ask again, until that's true. So you don't get out of the do loop until the while loop lets you. Pretty cool stuff. All right. Okay, here we are. We're in our we're just in our Visual Studio. Remember, I have my Solution Explorer up so that I can see my code and I know where my source files are and where my header files and all that up. So make sure your Solution Explorer is up. We have our include IO stream, and then I went ahead and threw in using namespace standard so I don't have to use the scope resolution operator, std. All right, we can just kick that one out. Just speed some things up. So let's look at our first if statement. We already talked about syntax, but this is what I did was I declared 3 variables, and they're all integers. So I declared an integer, and I said first num equals 100, and then this is inline initialization, right? So if we wanted to do every one of them by themselves, that's not a problem. Just use semicolons, right? So it's the same thing. It just, you can do inline or you can do it one at a time. It's up to you. It's going to be what's going on. So let's look at this right here. If what? First num is the same as second num, parentheses, body. What's going to run if first num is the same as second num? Same. Now if we look, first num is the same as second num. So if we run this, we're going to get the word same is going to print out to the console. And there it is, same. So because they're true, it's true, so if statement runs. Well, if they're not true, so now they're not true, so we're going to get nothing to the console because we don't have a default. We don't have an else in there, right? So now when we execute our code or run our code, we're just going to get our console and then it's just going to come up with nothing. So because there's no default. So if just did its own if thing, and now it's done. So another trick I'm going to show you, there's a shortcut. If you highlight everything, these are our comments. In Visual Studio, Control-Shift, backslash, and you can block comment. Okay? If you want to get out of it, Control-Shift. If you all the way, it's going to get. Both are ways to do block comments, and that's just a quick. That's just a quick shortcut that I put in so that we can speed through these without having me typing them. Now we're going to talk about our if else. So our if else, we're going to uncomment our code. Our if else says if first number is not the same as second number. So right now, first number is not the same as second number, so this block of code will run. Okay? Visual Studio, if you run it a bunch, it speeds up. If not, so they're not the same because 100 is not 200. So now that's true using a not operator. Well, if we make them the same, that means that's not true. So they're going to come out to the same because I have a default, right? So I have a default. So it's going to show me something either way. This would run. One of these is going to run no matter what. It's either true or not true. So one of these is going to run no matter what. And that's our simple if-else statement. And that's why it would be a tyranny operator, but we'll get to that later. So now they're the same. Now, what if I have a whole bunch of decisions to make? Well, I'm going to use an else if. So let's say I want to compare whole things, right? We want to all these things. Is first number less than third number? Well, right now it is, right? Is first number, okay, so it's going to check that. If that's not right, it's going to check this. Is third number the same as second number? And if that's not right, it's going to check another one. So we have this. We can string if statements along. We just use the syntax else if. And then look, we have this else. We call that our dangling else. Notice the important thing, else does not have a condition. Else is default. Something in this if statement is going to run, right? Something's got to run. It's either going to be default output if nothing above is true, or one of these three things is going to be true. Well, I know the first number is less than the third number, so less than is going to run now. Right? So first number, so then once it runs and hits the if statement, it's done. It is done checking and it gets out. Lazy evaluation we call it. So once it's done checking, it leaves. It doesn't even bother with these right here. It just goes on. Well, let's make first number greater than third number. So now first number is, so this is not true. Third number is not the same as second number, so that's not true either. We can make it true. First number is not the same as second number. Well, first number, so that is true. First number is not the same as second number, so this will run, right? So it's going to go down to the third option. And those are else ifs. If, else if, else if, else if. It kind of sounds like something from Frozen. We have this a wonderful amount of control in our program because our if statement allows us to have multiple if statements and all these different controls. So those are our if statements. When you play with them, you'll get really good at them, I promise you. But you just gotta write the smallest things to start with and just build these things. Build these little things like this and play with the values and the variables and see where it. We have our for loop. Initial true and a way to get to that condition. Well, what does this do? I is 0, I is less than 10. Well, 0 is less than 10. Add 1. So it's going to go in here and it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This will just run 9 times because we initialize for I is, right? I is 0. I will keep incrementing until it gets to 10, and it just runs 0 through 9. And no, that's 10 times because 1 through 9 is 9 plus 0, or plus the extra 1 is 10. So this runs 10 times. If we wanted to start at 1, start it at 1. Wherever you want to, this is going to run 9 times, right? Because it's going to start at 1, not at 0. Let's go 1 through 9. See? 1 through 9. So you can how many times your loop runs. And because these are variables, we can have user input or change it as the program goes. So that's pretty cool. Now our while loop. These are the exact same rules we talked for loop. Initialize, right? That looks familiar. Well, now it does. Initialize, condition to be true, and a way to get there. So if I took this out, this is just going to go 0 through 9, just like our other one. because it's just doing the same thing. It's just allowing us a different syntax in order to run the loop. Right? If I took this out, what happened? This would always be true. That would always be true, and it would just run. So not reaching the condition. We have to have a way to turn the condition off. Right? So this is just run, because it's just zero. So it gets angry. So that's going to happen sometimes. You might forget your condition. And here's our do while loop. Simple, right? What did we talk about earlier? We said initialize. Well, now I'm setting my j to 10. And then do this. Spit out while loop's running. And then make the condition so it stops the while loop. Initialize, condition, a way to stop the condition. Notice what I'm doing here. I was going plus plus because I'm counting up. Well, I don't want to count up. Let's say I was hired by NASA to write a program that launched a rocket. And they're like, all your numbers go from 0 to 10 and we can't launch. You have to count backwards. So, oh, okay. Well, I'll just start at 10. I'll print 10 and then I'll go negative, negative. So 10 minus 1, 9, 8, 7, 6, 5, 4, 3. So this will run, this will do this thing while j is greater than 10 or 0. Sorry, j is 10, and then j will become 9, and then 8, and then all of a sudden j will become 0, and 0 is not greater than 0, and the loop has to stop because it's not true. There you go. If we wanted to see the 0, we'd make it negative 1. We still haven't launched that rocket. They're waiting for 0. One more thing really quick, and then I want you to practice these if you can, okay? Just take 5 minutes, fire up your compiler and write a couple loops and stuff. Get used to fights. You'll become a better developer because of it. We can have decisions inside of our loop, right? So I just have an if thing. And now what this is the modulus. This just gives us a remainder. So I is going to be 0, and I divided modulus 2, the remainder is going to be 0. So any remainder divided by 2 is either going to be a 1 or a 0. So if it's 0, that means it's divisible by 2. If it's divisible by 2, well, geez, we know it's even. So we're just going to have a little thing to test how many numbers between, or we're going to print out the numbers between 0 and 100, even, and which one's odd. And we can do this really quickly because we just have a for loop. So you don't have to write this 100 times. You write it once and run it 100 times. That's loops do, but we can put anything inside of a loop. We put all sorts of things inside of loops. Loops are they're used for algorithm efficiencies and algorithms and everything. So now it just went ahead and it just did whatever was divisible by 2 is even, whatever isn't is odd. See, really, really quick. Python does it. You can do that with a step. But so these are our loops: for loops, while loops, do while loops. Our condition statements are if. So if you have an if statement, that just means you're going to want it to make a decision. Remember, when writing your if statements and you have an if else, this in young programmers, please don't put a condition on your else. Okay, because else doesn't evaluate. Else just does. If you're going to have multiple if statements, go to the else if. All right? Awesome. Functions next. Functions are awesome. Functions are going to allow us to start building a program outside the main. And that's the thing that we need to do. All right. I'll see you guys when I see you. Bye-bye.